Hello, this lesson we are going to continue establishing identities with trig identities. So we've discussed different types of identities, reciprocal, quotient, and Pythagorean identities. In a previous lesson, we also talked about manipulating this in a variety of ways. So if we take this and subtract sine squared from both sides, you can have this. So in a proof, we don't always have it a perfect way like that, but we may have it written like that. Oh, I forgot a square. And then you can substitute this for it, right? So I'm not going to rewrite all the different ways. That should already be on your toolkit. So some of the basics of proven identity we talked about. When you have this equation, the statement that you're trying to prove correct, we are only manipulating or working with one side. And the other side, you don't do anything to it. But at the very last line, the left side needs to be equal, identical to the right side. We pick the side that is more complicated. Sometimes it's on the left, sometimes it's on the right. And we've learned different strategies. So far, we've learned about rewriting trig functions in terms of sine and cosine. So breaking it down into smaller pieces, using Pythagorean identities. And for this lesson, we're going to talk about common denominators. So if we're looking at this is a little bit more complicated than previous problems that we've done. But we can see on the left, it's the more complicated side. We can also see that I have two fractions. So just like adding fractions, we're going to need common denominators. So our common denominator, if we're looking here, is going to be both of them. So it's going to be 1 plus cosine theta times sine. So what we're going to do for each part, we're going to multiply the other denominator. And what you do to the bottom, you're going to do to the top. Okay, so I'm just going to take an aside here. Right? So when we have common denominators, just in regular numbers, you would multiply, the common denominator would be 20, right? Multiplying these together, then you would have to rewrite the fractions, right? So you're multiplying 5 to the denominator and the numerator. Here you're multiplying the 4 to the denominator and the numerator. This is going to be the same thing. So the sign here, right? And this is what we're going to do for G. That's like 5 multiplied 5, 5. Signs over here, multiply there. And then the cosine, 1 plus cosine is here, so I have to multiply it to the top and bottom. So that's going to give us a denominator like this. And then we're going to, so it's sine times sine is sine squared theta. This, okay, a little messy, is 1 plus cosine theta times 1 plus cosine theta. So that's similar to 1 plus x times 1 plus x. So we're going to distribute, right? We're going to FOIL. And then this turns out to be 2 cosine theta plus cosine squared theta. And we're trying to get to 2 cosecant. So if we're looking at this, okay, you have to kind of see it. What do we know? Now, I didn't distribute the denominator. I'm just going to leave it like that. Hopefully something will simplify out. So we're going to keep it factored. So I can see this is sine squared theta, and this is plus cosine squared theta. Using your Pythagorean identity, this equals 1. So that's going to be 1 plus this 1 over here, 2 cosine theta Okay, I write really big, so I'm probably going to run out of space. Okay. So 1 plus 1 is due. Same denominator. Yes, you have to rewrite the denominator every time. Okay. Now I have the 2's. Now if I could factor, since they're both there, if I factor it out, it's going to look something really close to that. Excellent. So I'm going to just move that up here. So I'm going to factor out. So 2 cosecant is still on the right side. So factoring that out. Okay. What do we know? All right, so you can see this is going to go to that. So I have 2 sine theta. 1 over sine theta is the same as cosecant, which is the same as here. Yeah, they're equal. Identical. All right, so let's look at this one. All right, looking at the left, that is the more complicated side. And anytime you want to pause and try and do it on your own, that'd be excellent. And so the denominator here is 1 plus cosine theta. So I have a 1, so I can change this 1 to anything we want. So the common denominator I'm going to use is 1 plus cosine. So the numerator and the denominator for this is going to be the same. So this whole thing is 1, right? That simplifies to 1. So I just rewrote 1. Okay. So now it's the same denominator. So I'm going to rewrite this 1 plus secant sine squared. Now I'm trying to get to cosine. So I have a cosine here, but this is sine. That's the only thing that's kind of one that looks like it doesn't belong. Because this is cosine, this is cosine. So is there a way I can write this as cosine? And there is. I can rewrite that. Looking at the Pythagorean identities, hopefully you have it written down. Now if this is minus, you're going to have to put that parentheses around because I'm substituting sine squared out for 1 minus cosine squared theta. Okay. I'm going to change the sign here. That's going to go to minus. It's going to go plus. So this one and this one is going to go to 0. So we have cosine theta plus cosine squared theta. Okay, so are we close? Yes. So we're looking in the top in our numerator. Okay, I'm going to continue it up here. Is there anything in common? Answer is yes. I have cosine theta, and I'm going to factor that out. Right. So if you take out 1 cosine and you had 2 to begin with, you only have 1 left. So this and this they're both the same. That'll simplify to 1. So cosine theta equals cosine theta. Okay. So let's look at this one. Now, if you're looking at it, you're like, there is no common denominator. You're right. You're right. There is no common denominator because you're like, there's no fractions. Now, if you're looking at this, you would generally say, well, I can see that I should multiply that. It looks like, okay, I'm going to distribute. And then you're going to say, wait, but is there anything else I can do? We're going to say no. So we're going to go back to that first strategy that we learned, that if you're stuck, right? Is there a Pythagorean identity? No. There's no common denominator because there's no denominator yet. So the first strategy was rewrite things in sine and cosine. So this is cosine already, but tangent, can I rewrite it? Yes. Cosine, can I rewrite it? No. Can I rewrite cotangent? Yes. Okay. So cosine theta. Tangent I can rewrite as sine theta over cosine theta. And then this is going to be cosine theta, and this is going to be cosine theta over sine. So you're going to say, oh, Mr. Doza, these can go. All right. So I have sine theta plus cosine squared theta over sine. Now I have one that's a fraction and one that's not. So for my common denominator, I'm going to multiply sine theta over sine theta. Oh, sorry, there's no squared yet. Okay. So this here is going to be sine squared theta, cosine squared theta over sine theta. Sorry, didn't mean to do squared. Oh. So if you're looking in the numerator, sine squared theta plus cosine squared theta equals 1 over sine theta, and that equals cosecant using the reciprocal identity. Okay. So you just have to keep going and trying things and then just see what it looks like and just keep trying more things. Always refer to your toolkit and see if there's anything that looks like that line, similar to something that you're working with. Like for instance here, if you get to here, you're like, oh, looking at the Pythagorean theorem, it should jump out at you that equals 1. All right, don't forget to do the problem on your own and answer the EQ. Thanks so much for watching. Good luck. Bye.